to the day 2 introductory lectures of Control System Laboratory. My name is Sri Wilson and I'm going to present about PLC. PLC or Programmable Logic Controller is a computer-based device that is used for industrial control. And this is mainly used in automation tasks. Wherever we are repeating a task, we can do that with the help of a PLC. So this is implemented in elevators, security system, manufacturing machines and process plants. And also you can see PLC applications in assembly lines. So a PLC constantly monitors the input to see what is happening to its surrounding or what is happening to the process. Then it makes decision based on whatever logic we have programmed. Then it will control or adjust the outputs according to the change in the input. That way it will automate the process. So the inputs can be something like a switch which we will turn on to turn on the whole process, or it can be some push buttons, or it can be some sensors like color sensor which can be used to detect which color is being running through the process, or it can be a proximity sensor which says whether a product is there or not. Then outputs can be any type of transducers like electromotor, hydraulic or pneumatic jacks, or it can be some lights which can say what is the current status of the process. Then also it can be some alarm which will say some emergency is going on and a operator needs to check what is happening. So here an example is shown where we need to automate a process. This is a process mixer in which we have to mix the fluid before sending it forward in the line. So here whenever this empty sensor switch is turned off, that means there is no fluid inside the tank. So this is an input. At that time the output solenoid valve A is activated. That means the fluid will flow from here to the tank. Once it fills the tank, another input comes from this full sensor switch which says the tank is full. Whenever that happens, we will turn on the motor and that will mix this fluid. Once the motor is turned off, we know we have mixed this fluid enough. Then we can turn on the solenoid valve B and empty the tank. Once it get emptied, this sensor switch is turned off. That means we can turn on the solenoid A and repeat the process. So here we are also using some start and stop buttons, which is another type of input, and this says when we should start the whole process and when we should stop the whole process. This can be in the starting of the work schedule, and stopping can be the end of the work schedule. So we can see some sensors we used as inputs, valves and motor we used as outputs, and we are using their logical connection to automate this process. What does a PLC look like? So a PLC can be as small as that can be held in our hand, or it can be a modular PLC to which we will keep on adding some new input and output modules. So in the fixed PLC, there are fixed number of inputs and outputs, and customization is not, we cannot customize the number of inputs and outputs in that system. But for a modular PLC, it has enough capacity. It is like a big computer where you can add more and more inputs and outputs. Then how does this PLC operate? The PLC operates in a scan process. So every microsecond it will scan the program, and the inputs are always sensing what is its current state, and according to the program logic it will adjust the output. So in each scan it will read the input and adjust the output if there is any change in the input, and this is according to a program we have written. So this scan process is continuous and a sequential process. Then before PLC, we had to hardware everything by ourselves, and it was all messy, and customization was not at all possible because these all were relays. We are turning on and off something, and we have to hardware them, and they were not programmable. Then after PLC, it has become nice and tidy, and also it saves some space, and we can easily customize the program according to the future needs. Programming a PLC. What do we need to program a PLC? Of course, we need a PLC, which can be a fixed PLC or a modular PLC. Then we need a programming device. This can be a computer or some handheld device. Then we need a programming software. Then we need connector cable that connects inputs to the PLC or outputs to the PLC. Then some cables to connect between computer or programming device. Then the programming language used in a PLC is known as ladder logic, and it derives its name from the structure of that programming. So it looks like a ladder. And here we have two lines, one vertical line in the left hand side, one vertical line in the right hand side. The vertical line in the left hand side is known as the power source, and the vertical line in the right hand side is the power return. So each horizontal line connecting is known as rung. So here we have shown one example rung. So here we have connected switch to the left hand side of the rung, and we have connected a light to the right hand side of the rung. So we know that left hand side is power. It will come and stop at switch. Whenever you turn on the switch, this power will go through here, and it will reach the light, and it will turn on the light. So that's how the PLC works. So if it is turned off, the power won't go to the power return. That means light is not going to be turned on. So the left hand side where we connected the switch, it is known as the contact, and the right hand side where we connected the light is known as the coil. Contact says in what condition the power should go from the power source to the power return. And coil says what should be done when power is received. So in here, our contact says when our switch is on, transfer the power. Transfer the power. Then our coil says whenever we receive the power, turn on the light. And this can be some kind of output device like light, motor, or some pneumatic actuators, or it can be some type of internal relays. Then programming a PLC. So the program code we are doing for PLC is somewhat similar to if else statement in MATLAB or Python. So here the earlier we considered a switch connected to the uh, contact and light connected to the coil. In this case, it is similar to a if else loop in MATLAB as shown, because when our switch is on, we are going to turn on the light, or else we are going to turn off the light. Then now we will go through some basic concepts you need to know. So a contact can be normally open or it can be normally closed. So in a normally open contact, it works like how I explained before. When our switch is turned off, the power is not going from the contact side to coil side, or power source to the power return. But if we use a not option of this, whenever the X1 is not powered on or the switch is not powered on, we can send the power to the output. That is known as normally closed condition. So it is actually a not condition of whatever we have in normally open. So it is represented by a backward slash, and it says when our X1 is not active or it's not in a turned on position, send the power to Y2. Then here we shows how it works. So here you can see we have this is the switch X1 near to this 24 volt. Then we have not turned on this switch. If we have turned on this switch, there will be a power from here. So this is not turned on. That means for a normally open, there is no power for this switch, then it is not going to power on Y1. So the cyan in the background says whether it is active or not. So the not condition of this switch is right now active. That's why the power is going to the Y2. Then if we use the other condition, whenever we turn on the switch, we can see the cyan went into X1 and the power is going to the Y1. And in the not condition, it's not true because right now X1 is active. So it is not transferring the power from the power source to the power return. Now we are going to see some programming examples, and for first few examples I'm going to use two switch, toggle switch, which is similar to the switch we have in our home, that can be turned on or it can be turned off. Then we are considering an output of light, then these are connected to PLC. Then now if we want to turn on a light with a switch with a PLC, this is a simple program we can write. So we will use switch 1 X1 in the contact side and light Y1 in the coil side. So whenever we turn on this switch, power from the power source will go through here, it will reach the light and it will turn on the light. Now if we want to implement a AND logic, that means whenever we turn on both the switch, then only we should light the bulb. So this is how we can do that in the PLC. Here the power source comes and stops at X1. Whenever we turn on X1, the power will go to X2. Whenever we turn on X2, the power will go to Y1. If you are just simply turning on X1, this X2 is turned off, so power won't be carried to Y1, so Y1 is turned off. Or else if X1 is not active, X2 is active, that means power won't be coming till X2, so it is not going to turn on the light. Then to do an OR loop, like if any of those switch we are turning on, we want to turn on the light, this is how we can do that. So whenever we turn on switch 1, power from the power source will go through this switch and reaches the light and turns on the light. Or if we turn on X2, it again transfers power through X2 and it reaches the Y1. So to do an OR logic, we are creating a parallel line to this first line and we are connecting that back to the output. So we are creating two parallel contacts. And whenever we connect the contacts in series, they are going to act as an AND logic. Then for the upcoming few examples, we are going to replace the toggle switch with spring switch. So this is a normal switch we will see in some industries. So whenever we press down that switch, power will be there, and whenever we release, the switch will come back to its initial position, so power will be gone. So we are going to consider two switch 1 and switch 2, and the output we are considering a light. So first, if we want to turn on the light and maintain the light forever, we have to, so to turn on a light itself, we have to use some latching mechanism, because if there was no OR latch like this, if we press the X1, the power will go to Y1. Whenever we release the hand from the switch, the power won't be going from here to here, that means the Y1 will be turned off. But if we want to maintain that power, we can use an OR logic with this output in as the contact. What this means is that whenever X1 is turned on, the power will go to Y1. That means Y1 is active. So here Y1 is active, that means power from the source will go through Y1 and power it on the Y1. Then it will become a continuous power through Y1 to Y1. That way it will get latched. So here you can see one of the problem is that we cannot turn off this Y1 at any point. So to turn off the y1, we can use some unlatching command. So here in this program, we are using switch 2 to unlatch it. So whenever we press X1, Y1 is getting powered on. Then that powered on Y1 takes the power from the power line. It goes through this NOT condition of switch 2 and it turns on the light. So this will continue as long as you are not pressing the switch X2. Once you press the switch X2, then this condition will no longer be active. That means power won't go from y1 to y1. That means it get unlatched. That way we can stop the power to the y1. Now if we want to time some activity, we can make use of timer. So consider we want to turn on a light for 5 seconds after we press the spring switch. For that we can use a timer. So the timer, as long as it get powers, it starts to count down what time we are giving to it. The Then whenever that time is reached, it times that time, it will get activated. So whenever that countdown is done, it will activate the timer. So in our lab we are going to use a timer in which we will give the value in tenth of a second. So here k followed by a number is how we define the time. So if we give 50, it is going to be 5 seconds. And t0 is a variable name we are giving to the timer. So t0 will be active after 5 seconds. So the programming can be done as shown here. Whenever we press switch X1, it is going to turn on the light, and this light is latched to light with timer as the turn off condition. So whenever this timer gets active, this will be unlatched. Then we are using this light to turn on the timer. So when our light is on, this timer starts to count 5 seconds. Once 5 seconds is reached, this timer will get active and this will negate this condition and it will turn off the power to the light. And that means our timer is also going to be turned off after that. Now if we want to do another task, like whenever we press the switch one time we want to turn on the light, the second time we press we want to turn off the light, we can make use of a counter. So in a counter we have an enable condition that is saying okay, count 1 or count 2. So it is saying when we should count. Then we have a reset condition to reset the count number. So normally counters are represented by a variable named ct followed by a number, and the count number is given by k followed by a number. So here it shows how we can do counter in a program. So here x1 is a switch, and whenever we press this switch it is going to turn on the light. Then light is getting latched through the or loop, and we are making ct0 as the command as the variable that can unlatch the light. So here we are using counter. Here whenever we press the switch for one time, counter 0 becomes 1. Whenever we press it second time, this become 2. That means ct0 is getting activated and this will get unlatched. So that's all about programming. Now in our lab we are going to use a color sorter machine. As the name suggests, it can be used to sort some color of marble. Then we are going to do some task with sorting colors with marble. We have an hopper which will have all the marbles inside. Then we have a feed motor which can be turned on. Whenever we turn on this feed motor, it has a rotating marble collector that will collect a marble and sends into this rail, this slanted rail. Then it will go through this rail and it will fall down to the base. Then we have a color sensor in between that will detect which color is passing through this rail. Then we have 4 chutes where we can collect the marbles, and this is our PLC. We are using Direct Logic 205. And this is our control panel where we have three switch. One is toggle switch and two others are spring switch. Then if we take a close look in the rail, we have diverters for each chute. So whenever we open a diverter, we can send the marble into that chute. Then we have some chute sensors which will sense whether a marble is inside or not. Then we have gates which we can close to get a number of marbles inside the chute. Or if we are turning on, it will just go down and gets collected in this discarded marble pile. Then this is a class overview. So the class is going to be for 12 weeks. Yeah, and first half, that is first 6 weeks, some of you will be doing LabVIEW. The other half will be doing the PLC. Then after that 6th week, half the semester, during the 7th week, you will change it to LabVIEW will change to PLC. PLC will change to LabVIEW. Whenever that is happening, you have to submit a formal report on LabVIEW or PLC, and there will be a quiz as in the first class that is going to happen next week. Then for the next 6 weeks, you will continue with the same lab. Then in the 13th week, you will have a PLC practical exam, and also the reports are due during the practical exam for the second cycle of experiments. Then in the finals week, you will have a final exam. Then class policy, attendance is mandatory, and it's only exempted if you have any medical reasons. Then everything will be available in your Canvas, so you can go through chapter 1 in your lab manual to know about course policy, grading and syllabus. Then equipment, we don't have any backup equipment, so don't damage the equipments, because then you might not be able to do the exercise for the remaining part. Then help sessions from the 3rd week, we will have help sessions. So if you are feeling you are not on time with the schedule of the lab, you can make use of this help session. Plagiarism, we know there are so many old reports available there. You should not copy any old reports, or you should not copy from any other lab sessions. If we found out that you have copied, it will be a straight 0 points for plagiarism. Then course policy, there will be a final exam, so there will be one PLC practical exam, then there will be one written exam. Then the experiments will be conducted by a group of 2 people, and you can only share the results. Reports are individual, so each of you have to write your own report. Then manual is available in the Canvas. For LabVIEW, one of you should have Dartboard, my Dartboard, because from tutorial 7 you need to use the Dartboard. Then PLC presentation, so presentation will be in the 6th week of the PLC lab. So 1 week before, 2 weeks before, you will be asked to submit a proposal what you are going to present. So once you learn PLC, you know how PLC works, so you will conceptualize some concepts where you can use the PLC. Then there will be a quiz. So next week, whoever is starting LabVIEW, they will have a quiz in LabVIEW. Whoever is starting in PLC, they will have a quiz in PLC. And this is simply to make sure that you know what is going to happen in the lab. So there will be some chapters you have to read before coming to the lab. Then grading policy, you can find this in the lab manual. So LabVIEW report gives you 25 points. PLC report plus presentation gives you 40 points. Quizzes will gives you 5 points, and final examination is 30 points. 7.5 points for practical exam PLC, and 22.5 points for final exam, and that totals to 100. And this is how we have divided the grades. So I'm happy to take any questions if you have any.